to do the implementation, be it software, hardware, or whatever, then what is needed there, something like that. And you take a general factor, then also apply the life cycle, since the implementation process would involve the life cycle. Unlike kutiti factors actually planning in a factor analysis. I'm just giving my view. I don't know what others say.
Okay.
All right. Sorry. Hello. Hello.
Yes, Oxy.
Like, I am a visa. We are looking at something which has run volume, velocity, variety, and veracity. They are listed as factors. And now, what are the key factors that an organization must consider before investing on big data applications? Do you think it applies?
Well, I think footage should not apply as a safety since when we say volume, we are looking at the amount of data that we need maybe for a certain project. In this case, stands a roadmap. And total maybe kuti roadmap yacho considering kuti paroda volume of data yakawanda sei. Anyway, ndombrovunza kuti roadmap iyi kutaurwa iyi roadmap yekuita sei. Because
yeah, personal, what I think with that question there, could the V's, they also link to the project, to the big data cycle. So I think in English, they'll link my V's and then the big data cycle. Yeah.
okay.
Pane mama iswa na Christine na Courage in chat. Courage ataura zvema cost and budgets for setting up. Christine ataura zvema potential data sources. Like you are saying, kuti you also need to consider the type of the data that you want to, because you can't make a roadmap or make an implementation roadmap. Usingazi the amount of volume. Probably which are a system, large volumes of data, yet data are very big, and then it will be expensive for nothing. So those are some of the contributions that are coming from colleagues.
Okay, thank you. Okay. Any more contributions? Because I think we haven't really done justice. 10 marks. We need like 5 strong points. The good tongo that maybe we'll take and then can match the dog with the rano with the So from our presentations, Anga is from Group Mo. Apana Anga answer number 3A. And anyone can apply any contribution can they just put my chat box up and then don't go with the cloud.
All right. Next, can I just say something?
Yes.
From Janga Pane somebody abudisa point kuti determine what data you have and what data you need. Ndo yandiri kufunga kuti ndo volume. Because this is obviously the main characteristic that makes big data. It relates to the sheer volume of data that is being produced. The total amount of data is growing exponentially every year, so this is probably the most important.
Mm,
So I
okay.
think there's over like it's an emphasis yacho. Can I just read these notes on the determination of that? Consider all
Yes.
of the data types you currently have. That includes everything from user-generated data and website behavior to sales matrices, financials, location, data, RFID, streams, and more. Which data set contain insights related to your target use case or the problem you're trying to solve? For example, if you're looking to improve your marketing message, you might audit your system for data that contains information about what customers think about the brand, think NPS surveys, online reviews, and social media mentions. That's information that's some of the information that is there under what data you have and what data you need. So I think however way you write it, it's still talking about volume.
Mm.
That's the first one. Then the second one is saying ID gaps and silos in your data strategy. Once you've determined what data you need to gain the insights you are looking for, find out where it's stored. Find out where it's stored. Like I think from my visa, ningeachi variety student as more and more information is digitalized, you will start seeing more untraditional or unstructured data sets needing to be analyzed, such as picture, a social media post, a voice, etc. Structured data is easier to analyze as it follows a set of rules to frame a concept or idea. Structured data, however, is a relational database and is seamless and readily searchable by simple, straightforward search engine algorithms or other search operations.
Okay. Yeah, I think yama volumes kana munhu achigona kuilinka, it's one value point futi. And then pane document rasendwa noTonde mustudy group umomo rakashandisa ma-phases life cycle. So discovery pane learning the business domain, resources, framing the problem, and identifying key stakeholders. Don't you think that helps as well?
That's the best document. Life cycle.
Huh?
I think that's the best document. Because life cycle will be what?
And then data preparation, preparing the analytics sandbox, performing ETLT, learning about the data, and then data conditioning. I'm just reading through my main points. Survey and visualize, common tools for the data preparation phase, and then module planning, data exploration and variable selection, module selection, R, Python, SPSS, module building, it's another point here, life cycle pedu. There is okay, Panama main points are clear, but we are developing, and you develop and fit models on the training data and evaluate them against test data. And then you see if the model is valid and accurate on the test data. And then you check if the output is reasonable. And then are model parameters reasonable? Are there any intolerable mistakes? What? And then you go for communicate results. You compare the outcomes to the criteria defined for success and failure. You check if results are statistically significant. And then you create appropriate documentations, presentations of project results, taking into account various stakeholders. And then the last one is operationalize. You deploy the work of the project in a production environment. We use two-phase approach.
Yes.
Oh, sorry.
And I think, sorry. I think Tavemu need the right path here to follow.
Okay.
Move on, say, because I think Munesango agreed. He go to life cycle. So I think we can safely move on to the next question. This is Yango.
Sorry, maybe in the turn
Okay.
We don't also consider, I like the idea that we have taken, but then we also need to consider things like our resources as an organization. We are talking of financial resources and also technical skills. And also we are talking of our data sources. Like where are we going to get the data for us to implement a proper roadmap? And also we add up other things that have been said.
Okay, thanks, Mike. From this document you sent on a 20 group, looks like the resources, the data, my stakeholders are a discovery stage. So I'm not sure if discovery, I'm not quite sure kuti munhu anozove able here kuzoti come up nemamwe points, because it looks like akawanda anenge ari pachipa discovery.
I'm of the idea that I think the question is a bit clear, and it needs us to know what we need. It's more like what do you need for you to cook sadza? We need to know the upuati now. We need to know the number of people that are baripamba. Though the easier way to answer it is to say you can get the answers from the life cycle, but I think we need to mention things really like the problem that we are facing, define the problem, check our resources and as an organization. That is also cost analysis, benefit, the skills that we have, things like that.
Okay.
Sorry,
my points were to our life cycle. That's what you're saying?
Yeah, that's my thinking.
Okay.
If that's what you want, we are saying phase one, the discovery stage. On this stage, is learning the business domain. What is it that you're doing, that you want to do? Resources, framing the problem, identifying key stakeholders, interviewing the analyst, the analytics sponsor, developing initial hypothesis, identifying potential data sources. Those Chiripa discovery stage. Are we happy with the discovery stage?
Yes.
And then for phase two, that's that data preparation. It includes steps to explore, process, and condition data, create robust environment. That's analytics sandbox. Data preparation tends to be the most labor-intensive step in the analytics life cycle, often at least 50% of the data science project's time. The data preparation phase is generally the most iterative, and the one that teams tend to underestimate most often. That's what the preparation phase is about. And then for model planning,
Sorry, Oxu.
yes,
Sorry. There's something just sent on a courage. Can you try to go on it? Okay, Garrett, maybe can I just try to share the screen a bit? I think Chinenge Chirigu Taura is something which is a bit different from what people are suggesting. I'm not quite sure if it's like the true, it's the right thing. It might be good to understand that from my side, but let me just try and share the screen a bit. Only something chat to me.
Okay.
Okay. Okay, so like this is what Courage is saying on that issue, the implementation of a big data roadmap, right? Well, these are just the definitions. My uses, my big data using my some business example in the health, in education, in banking, in the government, big data in smart cities, the big data in retail, the big data in agriculture. Things to consider before big data implementation. Becoming data-driven is a disruptive shift, and really do organizations approach it fully prepared. As a rule, it takes a lot of preliminary work to develop a clear big data implementation strategy. Below is a list of important considerations to help you implement your next big data initiative. So those are the 4 questions which like you have to ask yourself before implementing the big data and data. The first one was, what data types will you be using to propel your organization towards the desired changes? Which data is relevant for your goals and can be discarded? Is the data inactive or moving through the network and in a constant use? The 4th one, how exactly will this data help you to achieve your goals? 2% of the big data implementation roadmap, right? So after you have made this consideration, you finally embark on a big data implementation project. The roadmap below may not fit into your organization perfectly, yet it should give you a structure you can fall back on as you implement the big data solutions, right? So maybe they like the roadmap. Kuti kutadza kunzwisisa here kana kutadza kulinga question yake to this what he has sent. What he has said, the big data implementation roadmap, where the first stage is like the identifying my data gaps. The second stage will be refine your existing data. The 3rd stage, choose your data analytics software. The 4th stage is coach your employees, and the 5th stage being assess the results and evaluate the progress. Like then they just tried to could define to explain further rather on what they meant on identifying the gaps, refine your existing data and choose your data analytics software. So maybe like why
ndio uye yacho ndo data analytics cycle yacho
ndo cycle
identifying the data gaps ayo ndo the discovery stage.
Discovery kubanza refine existing data inenge iri chima nje
ndo data preparation when you are refining preparing.
Unoona manje tiso yanoclaim kuti tichitoda takaona kuti ranzi chi-identifying the gap and thanks
saka advantage yecycle inokubatsa kuti usasiya, like in your model development there's no way you can leave these stakeholders because they are key and also they need to buy in terms of the system that you are building it.
Exactly.
So the cycle inobhatsa kupedza everything in terms of all the pieces they are joined together.
Saka maspaka things. So you can continue on it.
If it's necessary, but I was just thinking kuti pa topic 1 yedu iripo pane document nema slides ndakatinatsobva tokunyorera kuti pa discovery pane chi you attached identifying data gaps yaumbochiverenga notion pakatoudzwa kuti you are learning the business domain, my resources that you need, framing the problem, identifying key stakeholders. Ndozvitoripo zvakato elaborate.
Sakabo.
Oh, see, I think you can continue with presenting chapter B.
Ndizomirawo screen yakho.
Okay. Can you see?
Okay. How are each of these things important in big data processing? Parallelizable, data locality, coordination output. Ndingokumbira kuti munhu anongobata chake achingotsvaga mumwe achingobatawo parallelizable, mumwe achitarisa data locality, mumwe coordination, anenge angowana chaanenge angowana obva atouya achitionesawo kuti tinozviwana papi. Is that okay?
Mm. Papa Sina is in the group already.
Let me check. Mulobha muna vanhu here?
Yeah. I don't see anyone.
Okay, so the one big data locality. Kana ngamboiona here. Hello? So the importance of data locality, can you hear me?
Yeah, Drugunzo.
Data locality in Hadoop is the process of moving the computation close to where the actual data resides instead of moving large data to computation. So this minimizes overall network congestion. This also increases the overall throughput of the system. Kama importance acho maabata here. It minimizes overall network congestion. It also increases the overall throughput of the system. I think since in 8 marks, those two points are right, aren't they?
But basically, the data locality it can go show what location of your data in the system. With where is the location of data, something like that.
Are you sure? It's the process of moving the computation close to where the actual data resides instead of moving large data to computation. Tini, uskushandisa general knowledge here. But generally, locality is not going to
ndafunga kuti apa inogona kushow kuti the different sources where the data is coming from. Could I don't know, just from rekati Google it on.
Google Artizona is the process of moving the computation close to where the actual data resides, instead of moving large data computation. So we are saying we are just looking at the computation and we are moving it close to where the actual data resides. And if we go to a data race, we don't compute all the data. So they're saying the advantage of this, or the importance of this, is that it minimizes overall network congestion, and then it increases the overall throughput of the system.
I think Togono kind of need the other one, guys. This is just too much. And then if anyone has anything to say, I'm not going to go to even as we move on.
What one parallelizable coordination output? Just open
Hey, Oxen.
Yes, Kim.
Paona locality apongo struggle which say that don't put how is parallelizable important in big data processing. Parazota.
How is data locality important in big data processing? Ikabudisa, but parallelizable in high school Buddha.
And this is non giant to parallelizable, but it's Buddha. And the parallel processing system for big data analytics, which I think is different from financial truth strategies.
I think so too. Regarding which other notes, maybe you can get something.
And it's okay.
Handaida tobvunzawo kuti guys pana ane manotsi amwe asiri ari pagroup here asiri paGoogle Plus. Most of the stuff zvandiri kuona mumapeseni paper umu hazvimo manotsi amhomsora.
Manotsi zvirimo hausi kugona kuzviapply chete.
Most of the stuff, if you really look at it,
all right, let me just see what I can get. Issue naso atisegerereko kudai tunaisha manje.
iye parallelizable isi inonzi data parallelism.
Inogona kuve yakadaro handina zeti here para chakuti yacho.
and it entails partitioning a large data set among multiple processing nodes, with each one operating on an assigned chunk of data before participating in the process of combining the partial result.
And you. I think that's a good answer. Ngwakatsena waketsena waita sei kunasa?
Guys, chinaonera. Alright. Coordination iyo inini what I think hangu, though tichiri kutsvaga. But what I think is good, for example, in a Hadoop environment, there are different applications, but which anoshandiswa ese for data processing, for data analytics. So I think coordination, it generally means good team. We'll be using my different applications and different different applications in achieving the data analytics. And then all those on HDFS, we're talking of storage, all those things, cooperatively working towards data analytics.
Mumbovhuravhura here timu pane pamuri kumboona zvinhu njoga dzacho dzinenge dzarema idzi.
Mambonzo definition yangu ya coordination here.
Yacoordination tainzwa shamwari.
Because zviita kunge zvinhu zvacho zvisiko izvo. Pana ndichikuudza kuti guys zvinhu zvakawanda izvi.
Ndazokunzwisisa manje. Because ndavhura zvinhu nhasi kana ndakambozvivhura nhasi ndazvivhura. Kumbozviona zvinhu zvatiri kubvunzwa izvi.
All right, guys. Hi, everyone. Inini zvandiri kufunga from looking at the question and it pakanzi how are each of these things important to big data processing? If you look up pakanzi parallelizable and it definition yachona yandawana inini kwandiri it relates to basa reMapReduce. And Patruguti were breaking down the big chunks of data into smaller parts so that they can be, effectively worked upon. And two, we are talking about data locality. With this, we can relate to HDFS. And Patruguti open storage data, and it's within the system that we are using it. And you talk about HBase as well, because it's a form of storing, the data as well within the Hadoop framework. Then when you talk about coordination, it's in relation to Yarn, and it is yet another resource. Yet another resource negotiator, and whereby I was saying, Kutijoni, it's there's allocation of resources. My nodes Anenga are down is able to pick up. It's able to allocate my tasks within the different nodes in repo and things like that. And also, sorry to go back a bit, the data locality apple. We talk of an issue of data redundancy, and the data is stored in multiple nodes. And one node, if it goes down, we still have that data stored somewhere else because one replication of of the data stores in repo. What I haven't managed to pick out as yet is output. That's what I think.
Thank you so much, Angie.
Even per output, the one output is the production of the required information, which may be input in future. So, puzzling the difference between data collection and data capture. So, data collection by it involves getting the original data into the processing center, transcribing it, converting it from one medium to another, and finally getting it into the computer. So I'm not sure if that is the output that we are looking for.
Kero waita basa watoya zvipane kweseni yako yaya wanga watiza kai yakatokumirirai.
Mwana anodini nosheri iwe nhasi ndandisina kweseni. Alright, kweseni mbi ndandotovhunzawo ndandotonyara kuti ndanonoka kuuya ndotanga kusvika unovhunza zvinhu. Pane kweseni andandotovhunza number 1 kuti maianza sei.
Pakati parudiwa life cycle.
Thank you.
Sorry, Kero, number 1 ye section A composer cannot number 1 is section B.
Pane angakabhima question paper. Iri before yatiri kuita right now. Okay, sorry, it's number 1. Number A, iyo ine 10 marks yakabhimwa. 5 major factors to consider when creating a big data implementation roadmap.
Okay, iyo big data life cycle.
Thank you.
Can we move to a question? Discuss various types of analytics techniques and how they could be applied to different data such as call centers, call records, Netflix, video streaming, Twitter hashtags for new products and credit card fraud protection. hapana ngainayo here aripo.
I maybe ndoda kungobatsirwa papa. When you talk of my different type of my analytic techniques big data, ndopate chitaura here zvana machine learning, vana statistics, vana data mining, kana kuti something chinenge chiri different.
Personally, andisanda kutoziva.
Yeah, I think ndizvo, because nangoti data analysis techniques papatotanga kubuda izvozvo: regression analytics, quantitative research, text mining, factor analysis, data visualization, time series, data mining, sentiment analysis, quantitative analysis.
I think she's correct. Well, not I think, actually she's correct. Text analysis, neural networks, fact analysis. But now in this case, I think we might necessarily need to align the response to my types of zvapiwa apo izvo zvinofane kuti papiwa zvakaita sana Twitter neprogram ndopatinoita kuita vana sentiment analysis, zvakaita sema-core records, maybe probably akuenda kuda kunyepa, but we need to narrow the question with regards to example to those things zvapiwa izvozvo which determine our data sources.
Okay, sir. What is a question then? Okay. So we discuss various types of my analytic techniques and how they could be applied to different data such as call center, call records, Netflix, video streaming, Twitter hashtags for new products, and credit card for fraud protection. Maybe tikatora kind of text analysis and this. All right, maybe let's try data mining. Tiriko ku senda ukoko teta kuti takuzonotora like all that which was done by, which was recorded pa call center to just say exactly Mike. That's wrong.
Okay, I'll start angune what I can be able, like for example, number one, tataura zve-neural networks. Ma-neural networks togona kumashandisa for fraud prediction, credit card for fraud prediction. Anti ma-neural networks chetaungoreita okay, basically what we machine learning and all those things. Then in terms of Twitter hashtags here, I'll put it probably under sentiment analysis and maybe text sentiment and text analysis, so that we get we get my sentiment my clients or my views my clients pertaining a specific product. Then I think that's what I think, Angu, the way that you might answer the question.
And also call center call records atishandise here inonzi natural language processing, ndozvonana voice prediction kaizvi, where you can pick up a client kuti angari irate here and things like that. Were they happy? What kind of comments were they giving? Then Netflix video streaming. I'll need to think about that one.
Okay. Can I come in also? I want to ask you, have you already identified the various types of analytic tools which we have? Do you manage to identify them and single them, to list them out before we say we applied for this and for this?
We listed just a few. Sentiment analysis, data mining, time series, fact analysis, regression analysis, neural network, sentiment and text analysis, natural language.
Are these the ones which were been given by the engineer?
These ones are on Google. I'm not quite sure about my notes, but I'm gonna app.
Engineer akatipa some of these techniques and the analytic techniques. It's wise to use running akatipa.
Mumva mandishare manotsi aya because inini zvinhu zvakawanda ndongosangana nazvo paGoogle nemuquestion paper. Okay, manotsi zvirimo hazvo zvimwe but zvakawanda.
Okay, I think we may proceed if possible.
kutogoprosida usina kutipa here naiwe jedza sei wakadaro atakapuwa chipeka atakapuwa nainjiniya wakazvitanga rini zvikuru watete.
All right. All right. Engineer actually gave us these analytic tools, and these analytic tools that are engineer. They're also talking about issues of Netflix, TV, Netflix, what Anazinga, what she was also talking about that. And I'm trying to coordinate together. Right. These big data analytic tools, I'm trying to look for them. Forward right now.
Slide topic 3. Slide 5. Okay. Yeah, topic 3, 5, the fifth one.
Thanks. That's the one. Because I was knowing that spanning patakapiwa these tools. And the tools are machine learning. Question is analytic techniques. And so I will start by tools. Tools are fundamental mathematics. Then the second tool is statistics. Then the third tool is optimization methods. These are tools. And then we come to techniques. Question. We have 5 techniques. The techniques includes data mining. I heard you mention about that. Then the other technique is machine learning. Then the other technique is neural networks. The other technique is signal processing, and the other technique is visualization methods. So in the way how we have been coining them, actually you were touching on them, but some of them we were repeating them. For example, where you were talking about the sentimental analysis, where you say use sentimental analysis to do Twitter hashtags, and you were talking of, I'm not sure that I think when I'm repeat, but it is wise for you to single out the techniques to say, I will use data mining. Under the data mining, that's where I now use sentimental analysis, or I use this method, and this method. Then you go to signal processing. You talk about signal processing. You go to visualization methods. Then you talk about the visualization methods. Thank you, I submit, Chair. And even this is story more my explanations why are important. When you talk of machine learning, what exactly will you be doing, looking at? When you talk of neural networks, what exactly will you be looking at? When you talk of visualization methods and approaches, what exactly are you going to look at?
Thank you very much. Topindo.
As an offside, that is slide number 3. A lot of things I lecture about is that is coming. Kungo reminder, that slide number 3. Remember, she talked about the issue of acid and base. If you still remember, do you still remember? Patakata my parting shots. She talked about acid and base, comparing acid and base. That's where you see acid and base. Then she also mentioned about Mano SQL server. That's where they are, Mano SQL server. In case you haven't acquired yourself that slide, just to kungo panana utation web kungo babata babu. No SQL servers, acid base comparison, and then nitumito watakawana wataka kubata utututu. And I'm a fees of data. She also mentioned about that. Thank you.
Thank you, Jeremiah.
Gona chikoman.
Right, let's proceed. Normally we are heti kana unyarara kudai, so chichi kumisa. Can you proceed? Kana musat mapedza question.
Yes, winde pin. Okay, explain the 4 types of NoSQL. Much details will state and explain the differences between acid and base. The network file system.
All right, it's okay. I will take A.
All right.
The NoSQL databases. That's the one which I will take, while someone is also preparing for the second.
Sorry.
The NoSQL
Jeremiah,
databases,
just hold.
If the name suggests NoSQL.
Jeremiah.
Yes.
Mira tingo wana vamwe vari kufanira kubata iyo so that hatizomiri paunopedza.
Yeah, I've heard.
All right. Apana ruti batiro here. State and explain the differences between acid and base properties. Anyone who thinks anogona kuti yanga ingori mu slide zvatabva kuverenga. Then the network file system is one of the oldest distributed file storage systems while the Hadoop distributed file system came to the spotlight only recently after the upsurge of big data, clearly tabulate the differences between NFs and HDFS. This one I can take. I don't think it's being here.
Okay. So I'm continuing with question number 4A. Okay. 4A is explain the four types of NoSQL database. As the name suggests, NoSQL databases. Some they refer to these as non-SQL databases, which does not use SQL syntaxes or languages. For example, when you say SQL syntax, as you know that SQL is actually it's an abbreviation for, I don't know for what, but it's for query language. Maybe it's a sequential query language. Christy, what does SQL stands for?
Structured query language.
Structured query language or standard query language.
Okay. Structured query language, right? So no SQL languages, no SQL databases. Some they refer them to databases with no structured query language, right? But does not mean that there's no SQL somewhere. So it simply refers to non-relational databases, right? These are databases which actually does not create relationships between tables and using structured languages, query languages. The four types of these databases are actually column database, document database, key value database, and the graph database. Those are the four types of databases which are there, right? Some they call them wide column, wide column store database. So someone got column database cannot wide column stores database. Since Pans explain, I will start by the document database. Document database is a database which stores data in documents, right? Which are similar to, for example, the JSON here, JavaScript object notation, which is not JSON objects, right? Or maybe it stores database. Really, arima string chete, current arima numbers chete, or arima booleans chete, current arima arrays chete, or objects to become a document type of a database, right? Ndikangokupa example kuti Excel, right? You know what is kept in Excel. Excel, you are talking of figures there, is numbers. So it forms the types of what a database. Usually it's used to include my e-commerce platforms, my trading platforms, my mobile app development across industries. Those are some of the examples and information from these document databases, right? Examples of document databases: Paycheck, Coach DB, Mango DB, Cosmos, IBM Domino. All these are examples of what? Of document database. Then I'll quickly go to, since my marks are reported one day a little bit. There are four, so I think each in approximately 4 marks. I'm not sure. Then we come to key value databases. The key value database. It's a database with a key and a value, right? These are the simpler type of databases which you may have, whereby items or information there is denoted by keys. Good example, my shops. Shops. pane mabarcodes haya anenge aripo aya or mafigures chaiwo. Ukangoti item number 6, they will know kuti it's sugar. Item number Z, they know kuti it's chakati, depending coding yavanenge vakaita, and it becomes a database. Right? Vatori database ravanotoziva kuti ma-prices rinenge richiitwa in key. Saka inenge ichinzi key value database. There is a key and a value which comes from there. Examples of these databases, they include Oracle NoSQL database, React, Nana Zookeeper, ndo paanokwana ipapa. Right? Then we come to the wide column, column database, wide column store database. These are actually databases which are stored in tables, rows, and dynamic columns. Right? Normally the columns are often of same type and benefits from more efficient compression, making reads even faster. Macolumn chao ndo nyaya chenenge itoripo. So the column database normally can be quickly aggregated, and the value of given columns adding up in total. Unongofunga nezve column chete unoziva iwe mu Excel ye. Saka zvingori mu column ka ukangodai ungoisa case yako on top, you can know the sum, the average, and everything. That's the column databases. Saka if you are keeping your things, for example, angama information of stores of sales from various branches, ukangonyora ma branches ako on top, zvinoyapa zvesina ngati ma sales kune date. Saka by so doing, part one my tables, because you have rows and columns somewhere when the information is entering. Examples of these databases, they include Cassandra and Itigana, HBase, Vatica, Accumulo, etc. Then we come to graph databases, which is the fourth type of NoSQL database. These are database stores data in nodes and edges. In fact, edges in nodes and relationships. Right? My graphs, these are typically graphs. Right? Nodes typically store information about people, places, things, while this relationship stores information about relationships between the nodes. So it also talks about it gives information in graphical or in mapping and knowledge graphs for analysis mostly. Examples of this database, they include Arango DB, Infinity Graph, Apache Giraffe, MacLogic, Neo4j, Orient DB, Virtuoso. These are some of the examples of the databases that you know one about this. These are the four databases that NoSQL, which we may talk about. Thank you.
It's okay. Maybe we can do the part the acid and the base and it state and explain the difference between acid and base properties. Okay, when I'm going to go something really different from my slides there. When they talk of the acid model, once it provides a consistent system where the base model provides high availability. So the acid database transaction model ensures that performed transaction is always consistent. This makes it fit for business which deal with online transactions. For example, my financial institutions and online analytical processing, for example, data warehousing. The other one on the acid atomicity, consistency, isolated, and durable. When they talk of atomic, each transaction is either properly carried out or the process holds and the database reverts back to the state before the transaction started. This ensures that all the data in the database is valid. When they talk of consistent, a processed transaction will never endanger the structural integrity of the database. Isolated transactions cannot compromise the integrity of other transactions by interacting with them while they are still in progress. Durable, the data is related to the completed transactions. My acid case examples, financial institution will almost exclusively use acid database. Money transfers depends on the atomic nature of the acid. And then they talk of the base model. The rise of no SQL database provides a flexible and fluid way to manipulate data. As a result, a new database model was designed reflecting these properties. The acronym for base is slightly more confusing than acid. However, the words behind it suggest ways which the base model is different. So for the base, they're saying BA is basically available, S is soft or state, and E is eventually consistent. So basically available, soft state, and eventually consistent. So when they say basically available, rather than enforcing immediate consistency, a base model with no SQL databases will ensure availability of data by spreading and replicating it across the nodes of the database cluster. The soft state, due to the lack of immediate consistency, data value may change over time. The base model breaks off with the concept of a database which enforces its own consistency, delegating the responsibility to developers. Eventually consistent. The fact the base does not enforce immediate consistency does not mean that it will never achieve it. However, until it does, data reads are still possible. Cases of the base marketing and customer service companies who deal with sentiment analysis will prefer the elastic of base when conducting their social network research. Okay, so which is good for you? It is not possible to give straight answers to the question which base. Therefore, the decision must be reached by considering all the aspects of the project. So maybe on the differences, is the main difference, and I'm going to do the other one, the acid, it provides a consistent system, where the base model, it provides highly availability. So, and this is where Jeremiah can anyone on the slide, on slide 3, can you say no SQL databases, they fit in the base model? Can I could change something different, which would turn maybe with kind of phones were. I'm trying to question state and explain the differences. Maybe what could differentiate maybe between no SQL and SQL, and this maybe I need some help. Can I explain of my base properties? Nengo explain something no SQL. Watch it in doche base. SQL watch it in doche acid. From the main differences zakatsana ngurwa.
I think it's not gonna get us out our notion, because my acid properties are in the definition C what means consistency. So it means those my SQL database and the focus more in terms of consistency of the data. Yeah. So I think it can be used as one of the differentiating factor.
Thank you so much, Notion. Can I proceed with the part C?
Yeah, you can proceed. Let's say can we differentiate it? Can you state and explain my difference? Which kuma SQL and no SQL. But it's fine, you can proceed, I think.
Let's just, well, maybe somebody has got a response. Okay, let me just go through what I have. And if somebody gets something that they want to share, they can as well take us back. So the question reads, the network file system is one of the oldest distributed file storage systems, while the Hadoop distributed file systems came to the spotlight only recently after the upsurge of big data. Clearly tabulate the differences between NFCs and HDFs. So I've seen something per group about just reading something else that I have as well, so that munanungo know which one is of help. So I've grouped the differences. Ndichi tangane definition. The HDFs. It is a file system in which data is distributed among many data nodes or network computers, whilst NFS is a file system or protocol which allows its client to access the file over the network. So this is just the definition of the two.
Okay. Sorry guys. Network yanga yaenda akapati. Christy angachibvunza something about this issue of base and acid, and did
the notion.
I'm not sure whether ndiri kunzikwa because network yangu yambodona.
The notion angabvunza.
Oh, the notion. Great. All right. Thanks, guys. Apa takurova zvekuenda guys. Ndezvekungoti gagaga mukasire kubata tunhu. Issue iri papa guys, it's about when you talk of base and when you talk of acid, right? Kana paine paunongonyora zvekuti zvinhu zvazokunetsa unogona kuzongopasa uzonditengera madhiringi nerimwe zuva. Ukaona pakanzi acid
document name Jeremiah.
Andina document iri andina right now. Asi kungoti pandakamboerenga ndingotaura kuti when you know ukaona pakanzi base uona pakanzi acid. Base we are talking of no SQL databases. It's a theorem kana kuti it's the properties are associated with no SQL. Then when you see pakanzi acid, these are properties which have to do with the SQL databases, which are relational databases, as I've already mentioned in the previous question. Right. Base, as what notion have already mentioned, base it's an abbreviation which is complicated to track. Yaise kukrema zvakafana kuti acid. Pa acid uchingonzwa pakangonzi acid wakutoziva kuti A stands for atomicity, C stands for consistence, I stands for ndika kusvika pa D, right? But pa base manje it's like it's a three propertized thing which is basically available. No first property. Then soft state, that's the third property, and then eventually consistence, not eventual consistence, right? That's the third property. Saka it creates base. B basically A available. S panema S mavili but wakatra S1 soft state, and E wakatra eventually but apasona kuzotorwa consistency. Okay, so these are the we are talking of no SQL. Andika saka what is key in no SQL databases is availability. And what is key in relational where there is acidity, andika, it's consistency. So no SQL database anotanga asiri consistent. For example, ma key value stores or ma graphical database anangoita zvakangoita andika, but data really available zvakana wachirida unotorwana ipapo really available but really still consistent. Sometimes my duplications, a lot of redundancy, etc. Handika. But kwekuzondopedzisa kwaina kwaunozondoriwana kuoutput kwacho consistency inotanga kuzovapo eventually. But when it comes to acidity manje, we are think of a bank, you just think of a bank when it comes to acidity. Zvofana kutotanga tofana kutoclear ma duplicates toto clean data redu pekutotanga tanga totesa ma primary keys, you know, ma SQL andika primary keys auto increment what andika. Saka consistency is maintained from start. Okay, ndongotsanangura papapo nyango tisiri ndoda kuti mutongo magara matongo bata these properties tichito kuti zvisakunetsai. When you talk of database, when you talk of soft state, which is the element yekutanga yechipiri, I mean soft state, we are saying data rinopinda kurita available ndo chinotanga kumaintainiwa. Ropinda rini soft state, it's available for you to edit it, available for you to improve its performance, available for you to in soft state. You can play with it. And the state of the system may change over time, even without input sometimes. Right? Kuita kuti prepare for eventual what? Consistent. So those are the properties. Saka this one in this question when it comes to my properties, just know the acronym basis. Then if you explain it, you will be actually giving the properties of base. Then acid, just know those if you just say A stands for chakat availability, C stands for consistency, I stands for but if you just mention them now, you discover what are my properties. Thank you.
Jeremiah, sorry. A D availability ndio automaticity.
I think
A is atomicity. It's atomicity. Atomic should be small enough and complete in its units.
Do you have anyone Arutaura?
Nah, I think but I think I sent something once we group email, group WhatsApp. It's also like on the issues of my NoSQL and SQL, where the acid represents my SQL and the base represents my NoSQL.
Okay, and ndachona. And you about ansika kan ndongo any question yase.
Exactly, ndavana to ansika and do you have to apply that? But I think shinobva zvatobatsira.
Okay. So let me just share what I have. Tatu kutaura issue yema NFS versus ma HDFs and it. Tikati kana tichita ma differences. The definition is a difference because chimene chinenge chine definition yayo. So we start by defining, and then tati HDFs. It is a file system in which data is distributed among many data nodes or networked computers. Saka papa ninge paine issue ma computers akawanda ningari in question handiti. Then the NFS, it is a file system or protocol which allows its client to access the file over the network. And this one, we usually have just one computer entity. Then supporting data size. HDFs, it is mainly used to store and process big data. Then NFS, it can store and process a small amount of data. For storage, HDFs, its data blocks are dispersed on the local drives of hardware. Then for NFS, data is stored on a single dedicated hardware. Tichiri tesanditi. Reliability, HDFs, if data is stored reliably, then for here data is available even after machine failure. Ndopataitaura paya kuti inenge ine replication, sorry, file replication. So even if a machine fail, we can still get access. We still have access to our data. And then for the NFS, no reliability, data is not available in case of a machine failure. For data redundancy, from HDFs, it runs on a cluster of different machines. Data redundancy may occur due to replication protocol. So for my NFS, it retains on a single machine with no chance of data redundancy. Upon my NFS, no chance, there is no data redundancy. My HDFs, anoita data redundancy. Nishkonzero chekuti replication yaya tamboti is an advantage yekuti inoita kuti tisaluze data redu ndo inozokonzera redundancy. Then under domain, HDFs, it is for multi-domain. Then NFS is for single domain. Under client server trust, the HDFs, client identity is trusted by the operating system. Here, client identity is trusted by default. Then per NFS, it has different calls. It is mainly used for non-interactive programs. I think normal differences. And now, I don't know if there is anybody who wants to add something or even this or something.
Is it mean that I attempted 4B for December 2020? It was a similar question, but instead of NFS, it had Yarn.
You can present that one, Liz. Yarn versus HDFS, not versus NFS.
HDFS. Hadoop. Yes.
File systems.
Distributed file system.
Yes.
Okay. So yeah, that one. Let me see. I posted.
Do you have any document?
Any Oxy.
The documents that I have shared more. The other one I've shared more group. Then the other one it's sort of scattered. Share this up a machine, then I'll sort it out, then I'll send it as well.
Mabona.
Yes.
All right. But I think so. The question was saying define HDFS and Yarn and clearly explain about their respective components. So in a nutshell, Yarn is like a type of HDFS, but HDFS is like the mother. So the Hadoop distributed file system is a versatile, resilient, clustered approach to managing files in a big data environment. So, banana background sound up. HDFS is not the final destination for files. Rather, it is a data service that offers a unique set of capabilities needed when data volumes and velocity are high. It's actually a service that is offered for big data because we experience large volumes of data and velocity. It's in speed
need speed to transfer all our documents.
Sorry, Les, can you just come again? What is service? What?
And it's a service that is offered. It's a data service that offers a unique set of capabilities needed when data volumes and velocity are high, though Hadoop distributed file system. Okay, so I think maybe of interest is in a announce my name nodes and my data nodes. So as the service includes a name node and multiple data nodes running on a commodity hardware cluster and provides the highest levels of performance when the entire cluster is in the same physical rack in the data center. In essence, the name node keeps track of where data is physically stored. So there's a diagram here which depicts the basic architecture of HDFS. So in a nutshell, we are saying the Hadoop cluster in a commodity server in a name node. So the name node is the clever bit that then keeps information of where data is stored in the data nodes. The data nodes are not clever, so they rely on the name node for navigation, for direction to be of what needs to be stored in it. So those are the data nodes. Alright, data node. So these would be the community servers, 1, 2, 3, 4, going onwards, and then each name node. So it just basically contains like a set of instructions and engaji direct up to data node ita each cannot store this, cannot do, or you have this, we're retrieving now. Yeah. Right. It's quite a long document, but so HDFS works by breaking large files into smaller pieces called blocks. Called blocks. So the blocks are stored on data nodes, and it is the responsibility of the name node to know what blocks on which data nodes make up the complete file. The name node also acts as a traffic cop, as an entity node director. My traffic lights edashandisa tine mapurisa aya umbotiti endai mirai, managing all access.
Street father robots.
Exactly. Thank you. So managing all access to the files, haupindi pa robot paya kana pinda na mpurisa. Then including reads, writes, creates, deletes, and replication of data blocks on the data nodes. So our data nodes don't contain my data blocks. The complete collection of all the files in the cluster is sometimes referred to as the file system namespace. It is the name node's job to manage this namespace. Even though a strong relationship exists between the name node and the data nodes, they operate in a loosely coupled fashion. This allows the cluster elements to behave dynamically, adding or subtracting servers as the demand increases or decreases. So we're just saying my cluster elements are, when we say dynamic, it means there's movement. So we add servers as the demand increases. We we subtract servers as the demand decreases. So no dynamic wacho, they are not static. So in a typical configuration, you find one name node and possibly a data node running on one physical server in the rack. Other servers run data nodes only. Okay. Things will not get but data nodes are not smart, but they are resilient. I guess they are politicians. Anyway, within the Hdfs cluster, the data blocks are replicated across multiple data nodes and access is managed by the name node. The replication mechanism is designed for optimal efficiency when all the nodes of the cluster are collected in a rack. So kunenge kune rack ID and all right, so maybe let me read this. Big data brings the big challenges of volume, velocity, and variety. As covered in the previous sections, HDFS addresses these challenges by breaking up kungowedzera information just in case tinogonozowana imwe question inenge ichitaura kuti relate to big data, how HDFS can assist or is important or is relevant to us, to big data. So HDFS addresses these challenges by breaking files into a related collection of smaller blocks. These blocks are distributed among the data nodes in the HDFS cluster and are managed by the name node. Block sizes are configurable and are usually 128 megabytes or 256 megabytes. I remember Oxy presenting on this. Achitima 128. So meaning that a 1 gig file consumes 8 128 megabytes blocks for its basic storage needs. So okay. All right, now Yarn is called yet another resource negotiator. So Yarn is a core Hadoop service providing two major services. Maybe let me read it again. Yet another resource negotiator is a core Hadoop service providing two major services, which is global resource management, which is resource manager, and then pay application management, application master. So we're saying the resource manager is a master service and control node manager in each of the nodes of a Hadoop cluster. Saka, this resource manager, inoto controller, neku manager each of the nodes in a Hadoop cluster. That's what it's saying. So this one is the one related to Yarn. So the only difference that I saw there was they are fragmented. Okay, let me see. I think here each is standalone, unlike Consoro ko Panam, where the resource manager or the name node itori included in cluster match. So that's what I just noticed. And this is separate. We go back this one. So it's like there's a node manager, Yeta app master, ne container, node manager, app master, ne container. But all these app masters and containers, they communicate by chow in between. Like you see the arrows, each independent communicator here. So I don't understand. There seems to be a map reduce aspect. I think if you see a Papagan's map reduce status, doma arrow ma solid arrows. Oh, so whenever there's a container, it okay, I don't know what map reduce in it and that's varying, but it sort of performs what it's supposed to do, giving the app master. The same here, this container is I think map reducing to app master issue. The same goes here, container, app map reducing to app master. Okay, so the fundamental idea of Yarn is to split up the functionalities of resource management and job scheduling or monitoring into separate daemons. Okay. Saka zanachitara kuti akato separate because apparently like multiple node managers, unlike with the HDFS, the first one, there's a single name node, and then that's the one that communicates with all the other data nodes. You see, no communicator among ASA. But this one seems to be more efficient because it has more node managers. And my bond. Anyway, I think for further clarity, you can just read through, but that's the gist of what it was saying. So once again, I'll just read the question and then you can comment according to what you heard. Define HDFS and Yarn. I think we've done both. Then and clearly explain about their respective components. So I think the diagrams are a must, and the respective components are they are name nodes, data nodes, and then in a Yarn there's the node manager. In each is a resource manager and an application master. I think that's it from me.
Hi, Leslie.
Yes, Angel.
Beautiful. From what you're describing, Rita, I managed to pick up that you're kind of. You're mixing two things.
Okay.
Yarn and HDFS may produce. Those are the three main components of the Hadoop file system. And it is like when it was initially created, those were the three main things that were there. And
right.
Then we have add-ons that we have within the Hadoop ecosystem. Let me just bring this.
So you're saying Hadoop mune HDFS, Yarn ne
produce and other components.
Oh, and other.
Yes. Actually, it was a question to it. So you see here, Panapa. The purpose here Hadoop HDFS. It's for data storage.
All right. Yes. Because of the data nodes.
My name nodes and my data nodes. Those are the components of the chip of the Hadoop
HDFS.
Then Yarn yakazvimirira yega. It's a cluster resource management.
Okay.
Yes. Then we have MapReduce. This one stands for data processing.
All right.
So these are the core of the Hadoop ecosystem.
Then tochizoita mamwe ma-add-on aya ari kuno kwayo ari kunze aya. These are ma-add-on ane ma-different responsibilities. Kange zvakanyorwa apa kuti for data collection and injection we have scoop, we have flume. Then for scripting we have pig and hive for SQL queries. Real-time data analysis, Spark, monitor your machine learning and other things like that. We have also Mahot, which is machine learning and everything. Then we have Apache Ambari, which oversees the whole system. Then we have Kafka and Storm, which is for streaming data and data like we're talking of volume and velocity and so this takes care of that. Then we have security, because whenever you have data, you have to make sure that whatever is coming in and whatever is going out and what you have in the database already has to be secured. Then we have also the workflow system.
Okay. So I think still the diagram that I put even for Yarn applies, because until it cluster resource management, Yarn is two components that it works, that it relates to.
Exactly. You have the resource manager and the other one. And
the application master.
Yes, the application master. So what I'm just trying to say, Kuti, they are not things that are comparable.
Okay.
Like how you were putting it, compare. They are not comparable because they are two different things, serve two different purposes.
Okay.
Yes,
all
you
right.
can't. The thing that you can maybe Chonga equated HDFS to is H-base, and it is.
Right.
But again, H-base.
What is the Hadoop aspect?
Not the Hadoop aspect. It's for data storage. We are saying that HDFS is just for data storage. Then the other thing that you can have, which is similar for data storage, is H-base.
Okay. Hello, Angel.
Yes.
All right.
All right. And then I am also with you on this issue. Can I compare zvinhu the same purpose? Like yandaita kuti ma HDFS nema NFS was SR2 ndeye storage. But when it comes to Yarn and HDFS, they are two different components of the same thing. They are part of the body. But I think I compare
exactly.
And then pane futi rimwe statement rataurwa less animal components, you've got the right components, but I think for try the application part ndo iri kuti nzvenge kuti you are sort of applying you compare yet zvinoseva mapurposes akasiyana. And then one other thing pama HDFS my nodes is 128 it's ingori at the default size yema uye, but put the purpose yema HDFS ndeyekuti data redu nekukura kwaro tigone kurestore. Saka as the size ye data rako rauda kustore ndo inozodetermine kuti iwewe unoda kuti manodes ako ange aine size ipi. Because hazvibatsiri kuti une terabytes of data ubva washandisa manodes ane 128 KBs. And it, I think Angel, if you can continue any question yako ika zvinogona kutibatsira. Handizivi kuti vamwe vanokuona sei.
Yeah, because tovatangobata zviri similar.
Sorry guys, ndokumbira kungoita come in before Angel continue. Angel, document inonzi Hadoop ecosystem yako isei isina zookeeper. Zookeeper ndakabata kuti ndiye gatekeeper here, ndiye manager kuona kuti zvoni ecosystem medu animals ari kugarisana mushere.
Question yamuri kupresenta ndeyekuti chikwe.
All right. The original question is explain HDFS and Yarn, including their components. But the main reason why we have this screen, we're just trying to guide Lacey because she had presented something on this question, but she was mixing two things. So we're just trying to explain to her kuti zvinhu two zvakasiyana. That is why we have that Hadoop ecosystem iri apo iyo.
Okay, it's okay. His
Okay.
network yangu yangamboni put out.
Alright. Angel, ndandapedza. Ndine question iyo yekuti document rako harina zookeeper. Ndaifunga kuti zookeeper akakosha muecosystem. That's number 1. Number 2, nandichida kungoitawo contribution yangu maybe pane nyaya yeYarn neHDFS yanga ichitaurwa naLeslie. Muchingotsigira Oxe yanga achiti these are 2 different things. Pakuti inini pane document randakaonawo rine ecosystem yandakashandisa